All right, today in Unit 3, we're going to be looking at solving systems of inequalities. So we want you to be able to solve where an inequality is involved. Remember, that's less than, greater than, those types of symbols. All right, so the first one on your note sheet, a little word problem here, says during one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. It is expressed as a maximum over a minimum. For example, your blood pressure might be 20/80. Normal blood pressure for people under 40 years old ranges from 100 to 140 millimeters of mercury, and maximum 60 to 90. Okay, we want to express this as a set of inequalities. So first we got to figure out, well, what are we going to call these things? So let's use X for our maximum blood pressure, and let's use Y for our minimum blood pressure. So if we read here, normal blood pressure ranges from 100 to 140. That means that our max here should be, our maximum blood pressure should be greater than or equal to 100. But we also want it less than or equal to 140. Doing the same thing here for minimum. It's got to be between 60 and 90. So minimum, we're going to use Y. Y should be greater than or equal to 60. And we want it less than or equal to 90. Now we have a system here of inequalities that describes the blood pressure. What you could do now is graph something like this out, and you get a chart like this. Okay, the x-axis here, that's our maximum, like we said. Our y-axis, that's our minimum. If we were to graph these lines out, we would get it. Remember, when you graph a x equals equation, these are vertical lines. And when you graph y equals ones, those are horizontal lines. Okay, so if you graph, here's the 100 and the 140, those are both vertical lines. If it's less or greater than 100, that's kind of graphing everything over here. If it's less than 140, that would be kind of graphing everything less than that line. That would be in here. Notice the overlap and shading happens between these two lines. Okay, if we do the same thing with the y lines, greater than 60, that's kind of everything above this horizontal line. Less than 90, that's everything below this line. So here, again, the overlapping occurs in the middle. Well, since the overlapping occurs in the middle for both of these, the part that all four of these lines would have in common is this box right here. As long as your blood pressure falls in that box, you have normal or healthy blood pressure. So this is the overlapping of all four lines. And that's what we're going to be doing today when we graph these out. Where does all the overlapped shading occur? We want to find that location. All right, so going on here. This next one says Classy Catering needs at least 15 food servers and 5 bussers to cater a large party. In order to make a profit, they can have no more than 34 food servers and 7 bussers working at an event. Write a system of inequalities for this. All right, so let's make it easy on ourselves. Let's use F for the food servers. And let's use B for the bussers. Okay, so let's see if we can write some inequalities here. We know Classy Catering needs at least, that's a key word we've had before, 15 food servers. At least means equal to or more. So one inequality we can get from that is that F has to be greater than or equal to 15. Okay, and they need at least 5 bussers. So again, we want to use greater than or equal to bussers. We need to have at least 5 in order to cater a party. All right, but to make profit, they couldn't have unlimited servers. They got to pay all these people. So they said no more than. We've had that keyword too. That means less than or equal to. Okay, so for food servers, we have to be less than or equal to 34. For bussers, we have to be less than or equal to 7. Otherwise, we're paying out too many people. Now we have a system of inequalities that represents this situation. And for this problem, that's all they wanted us to do is to get to that point. So that would be the answer. Later, we're going to have to probably graph a situation like that out as well, similar to how we did in the last problem. Okay, for number 2, now they give us some inequalities. They want us to graph it out and figure out where is that region where all the overlap happens. Okay, so first one we want to do, we want to graph one of these lines. Let's graph this one right here. Let's graph that first one. Lucky for us, this is in slope-intercept form. So we know on this one we can start at 4. Okay, that's our y-intercept. Our slope here is -2. If it's a whole number, put it over 1. Okay, that's saying down 2, right 1. So we want to keep doing that. Down 2, right 1. Down 2, right 1. Down 2, right 1. Okay, keep going until you run out of space. Now, we have to connect these. Now, remember when you're graphing inequalities, there's 2 types of lines that you want to use. If it's greater than or equal to or less than or equal to, you want to use solid line. If it's just greater than or less than, then you want to use a dashed or dotted line. So here we should be connecting these with a solid line. Okay, but again, we're not done here. If it was equal, if this was an equal sign, we'd be done, but it's an inequality, which means there's many solutions that make that true. We want to decide which side of this line is going to make this true. We know the points on the line make it true. Which side of this is going to make it true? So to do that, pick a test point, and the easiest test point we always said is 0, 0, unless your line actually goes through the 0, 0 point. Here it doesn't, so we can use 0, 0. So let's put 0 in for y, and let's put a 0 in for our x, and see what we get. Well, if we put 0 in for both, we get that 0 is greater than or equal to 4. That is a false statement. 0 is not bigger than 4, which means our test point here at 0, 0 does not come out to be true. Any point we pick on this side of the line is not going to come out true. So that means the other side of the line must make them all true. So in this one, we'd want to shade everything over here. Okay, so that's for the first line. Now we got to do the same thing for the second line. We want to graph it on the same graph. Again, it's in slope-intercept form, so start at -2. The slope is, there's nothing in front of this x, so we know it's a 1. And just like we did before, we can put it over 1. It's a whole number. So 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? Or we could go down 1, left 1, down 1, left 1. This is going to be a solid line because it's the or equals to. So the boundary line itself does include answers. And then we want to check which side of the line makes this one true. Again, plug in 0 and 0 and we can check. We plug in 0 and 0 here. We get that 0 is less than or equal to -2. That is, again, false. 0 is not less than the negative numbers. It's bigger than the negative numbers. So the origin, again, it comes out to be false. Any point we pick over on this side is going to come out false. So we want to shade on the opposite side. We want to shade everything down here. Okay, so now looking at this graph, our answers, or our solutions are in the region that is overlapped in shading. Okay, and here, it's right here. Any point in this region of the graph makes it true. So what you want to do is heavily shade in that section. That is your, any point in that region is your solution. We're going to refer to this as the feasible region. That means any point in that feasible region. Feasible means something that's possible is a possible answer. Let's try another one. On this one, number 3, we want to graph these two. The top one, we're going to come back to that in a second. Let's do one that you're a little bit more familiar with. Why don't you pause the video and try graphing this one quick. Make sure you shade for it and see what you get. All right, let's test out and see how you did. So for this, y is greater than or equal to x minus 1. It's in slope-intercept form. Start at -1. Slope is, there's a 1 in front of there. 1 over 1 is the slope. Up 1 over 1. or you could go down one, left one. It's or equals to, so we want to choose a solid line to connect these with. Now to check the shading, if you plug in 0, 0 as a test point, you're going to get that 0 is greater than -1. That's true. So we want to shade on the side our origin's at, which would be here. So you should shade everything on this side. Okay, now we got to graph this other one, and the other one's a little bit harder. We haven't maybe graphed one like this before. What does this line look like? Well, we just got done a few chapters ago looking at absolute value. Okay, absolute value means the distance from 0. So we want all the points that are less than 3 away from 0. So that can mean that y here is less than 3, but it could also mean that it's greater than the opposite of that, which is -3. So we want to graph out all the points in this region. Okay. To do that, you could kind of split it in half. Look at each part separately here. One thing it would say is that y needs to be less than 3. So on our graph, let's graph that one out. What does y less than 3 look like? Well, y less than 3, y lines, that's our intercept, okay? There's no slope. It's kind of like plus 0x. There's no slope with this one, but we still want to start at an intercept of 3 here, okay? And if it's a slope of 0, that means it's a straight across horizontal line. Okay, so we want to make a horizontal line going across through that 3 point. Notice our symbol here. It doesn't include the line, so this would be a dotted line that we want to use here. So that is for that part of it. Okay, and it's less than, so we want to shade everything less than this line. So anything below this line should get shaded in, because all the numbers less than 3 would be below. Okay, let's graph the other part of this line. Right here. It says that -3 is less than y. If we were to switch that around so that the y is on the left, -3 is on the right, notice our symbol's pointing at the -3, so let's have it continue pointing at the -3. This is saying y should be greater than -3. Okay, that's another one in slope-intercept form. So if we start at -3, again a slope of 0 on this one, and we should connect it with a dotted line. Okay, this one says this is a greater than symbol here. All the numbers greater than -3 are going to be above. So we want to graph everything above the line here. Okay, so which region is the region where all 3 of these overlap? It would be right here. Okay, this is where all the overlapped shading occurs here. So that's the section you want to heavily shade in when you're doing this. So that would be the answer. Any point in that section includes our answer. All right, so when you're doing this, use your, probably for the first, when you're shading in each line, shade it lightly, and then when you're done, kind of shade the darker in for the final one. All right, let's try another problem here. It says solve these ones by graphing. So we want to graph each line out here. These ones shouldn't be too hard. They're both in slope-intercept form. So let's start with that first one here. +4, 1, 2, 3, 4 right here. Slope is 1/4. That means up 1/4. Or we could go down 1, left 4. Okay. It's going to be a boundary line that's dotted here. And then we need to figure out which side to shade on. On this one, if you put 0 and 0 in, you're going to get 0 is less than 4. That's true. We want to shade on the side of the origin here, so let's shade on that side. So we'll do some shading here. So we'll shade everything here. Okay, for that one. For our next line, start at -2. Slope is again up 1/4. So we know that these two lines are parallel. These two lines are not going to intersect. And this one we want to use a solid line because it has the or equals to. So we want to see where this one shades and where the overlap happens. So if you pick a test point, let's pick 0 again. We get 0 is greater than -2. That's also true. We again want to shade on the side of the origin. So that means we should be shading above this one. And it looks like the overlap in shading happens everywhere between these two lines. So this is the side you'd want to shade in dark. That's where all the overlap happens. So that would be all the solutions. Now, when you get parallel lines like this, this would be the one time where you could maybe not get a solution. If you were to graph two parallel lines and maybe one ends up getting shaded above and one gets shaded below, okay, and no overlap happens, that would be the one case where you might not end up with any solutions with these systems of inequalities. That's where you would say, since no points make both of them true, there'd be no solution. All right. This next one. Now we get two lines, and these ones we want to graph too, but they're not in slope-intercept line or slope-intercept form. So if they're not in slope-intercept form, there's kind of two ways you could go about doing this. One would be that cover-up method we talked about. So you could cover up one of the variables and see what the other one is. So for example, on this first line, if we were to cover up, say this one, okay, then it looks like x ends up equaling -1. So on the graph, what you could do is come over here and find where -1 is and put a point. Okay, then you could do the same thing with the y. So if you cover up the x, what's the y going to equal? So if we divide this by -1, looks like y ends up being +1. So then what you'd want to do on this one is put a positive, find where +1y is, and put a dot there, and then connect those with whatever type of line. Looks like this one's supposed to be a solid line. And it looks like the pattern here is up 1 over 1, so if you just continue that, the line would look like this, and we connect them with the solid line. So one way to graph those is that cover-up method that we've previously done. For this one then, again, we need to choose a test point. So if we put 0 in for both x and y here, 0 minus 0 is going to be 0. Is 0 greater than or equal to -1? Yes, 0 is bigger than all the negatives. So we want to shade on the side of the origin here. So let's shade there. So everything in this side should get shaded. Okay, for the second line, we could do cover up again. Let's try another method though for this one. The other way you could do this, if it's not in slope-intercept form, is get it in slope-intercept form. So if we're going to get this one in slope-intercept form, we want to get y by itself. Okay, so one thing we could do to get that, minus 3x to the other side. That cancels out, so now I got -y is less than or equal to -3x plus 4. Okay, but we don't have y by itself yet. We still got this negative. It means that if there's a -1 here, let's divide everything by -1. Okay, so if we divide everything by -1, that cancels out. We got plain old y. -3 divided by -1 is +3x. +4 divided by -1 is -4. Also, this is an inequality. You recall that when you're dealing with inequalities and you multiply or divide by a negative, we also need to switch the sign. So the sign should go the other way on this one. So now we want to graph out this line right here on our graph 2. Okay, so we want to start at the y-intercept of -4, put a point, and then we want to do slope. On this one, it's 3, any whole number you can put over 1, so we want to go up 3, right 1, up 3, right 1, up 3, right 1. This one also has the or equals to, so choose a solid line for our boundary line. Okay, pick a test point. Let's go back to 0, 0 again. Is 0 greater than -4? Yes, 0 is bigger than all the negatives. So again, we want to shade on the side of the origin. So let's do that here. And if we shade in, if we shade in here, everything on this side, it looks like we get this area in green here. That's where our overlap is. That should be the part you shade in. That's where our solutions are. So this is our feasible region right in here. Okay. So if it's not slope-intercept lines, then try to get them in slope-intercept lines or slope-intercept form. All right, this last one, we want to again find out, graph this one out. There's also an extra thing they want us to do here. They also want us to find the coordinates of the vertices, and we'll talk about that in a second. Let's graph this out first. The first one's in slope-intercept form. Be careful here. They kind of throw a little curveball at you. This one, the x isn't first, so if you want it first, if you're used to that, maybe rewrite it here. Our y-intercept is at 3. Our slope here is -1/1. So go down 1, left 1. Keep repeating that. Can repeat it on the other side. And this one we want to connect with a dotted or dashed line here because we don't want to include the points on the line itself. All right, now we got a shade. Okay, so pick a side and shade on. And on this one, if we put in 0, 0, it looks like 0 is less than 3. That's true. We want to shade on the side of the origin. So everything here should get shaded in here. All right, next line is y is greater than -1. Okay, that's a slope-intercept line too. It's just not, they don't really have the slope listed. It would be like plus 0x. So we want to start at -1 and have a slope of 0, which means horizontal. This one is a solid line because it could be or equals to. And it's greater than, all the numbers greater than -1 are going to be above the line. So we want to shade everything here that would be above that line. So if we do that, yeah, everything here. We want to shade all this up. All right, the final thing now that we need to do is graph the last one. This is not a slope-intercept form line because there's no y involved. It's just x greater than -1. This is a vertical line. Find where -1 is on the x-axis, right here. Okay, so it's a vertical line through there. We don't want to include the line. It doesn't have the or equals to, so it's a vertical dash or dotted line. And it's greater than -1. All the points greater than -1 are to the right. So we want to graph everything. So graph shading this in, everything to the right. We get this. Okay, and you can now see where our feasible region is. It would be this triangle right in here. So this, anything in this triangle is our answer. Okay, so that's graphing it. The last thing they want us to do is figure out what's the coordinates of the vertices. That's where the lines bordering this feasible region intersect each other. Okay, so there, if it's a triangle, there's going to be 3 points. 2 of the points are pretty easy to see. One's right there. So we got 1 point at -1, -1. That's one ordered pair that is a vertice of this feasible region. Okay, another one occurs over here. Okay, so then again, find it. Now we know that for sure. That's going to be at -1 here. Now you got to see where these intersect. It looks like it's 1, 2, 3, 4 over there. So 4, -1 would be another one. The last one is where it intersects here. So find the ordered pair there. We know it's going to be at -1 because it's from this vertical line here. And then it looks like it appears to be up 4, so -1, 4. So those are the vertices of feasible region. All right, try out your worksheet, doing some